All right, we're going to do some trigonometry. Welcome to trigonometry. So, what we're going to do in this class, in this lesson, it's going to talk about trigonometry, and we're going to worry about the trigonometric ratios. So trigonometry, that's three. There are three ratios that will help us be able to solve for angles of a triangle and the sides of a triangle. And so what you have to start with is the basics. The basics. So there's an acronym that we will use in this class to help you with trigonometric ratios. So the acronym is sine, cosine, tangent. So there's the three functions. These are the three functions, and they on your calculator they're sin, cosine, tangent. Those are your abbreviations, and you'll see them on your calculator. Now, what you're going to realize is this: each of these words represents a letter and a name. This is only used on right triangles. If I have a right triangle, let's label very quickly. Across from the right angle is always the hypotenuse. And these are going to be legs. Now, if I have an A, what we would say is the leg that is on the same level as that is adjacent, and the leg opposite it would be opposite. So that's the drawing you're going to need to be able to do this. So watch carefully. Sine, you're going to do opposite over hypotenuse. So it looks like this: sine A equals O over H. Cosine, the adjacent leg over the hypotenuse. So cosine equals adjacent over hypotenuse. We'll do OPP. All right, and tangent is the opposite over the adjacent. Tangent, oppo over adjacent. So these are our three ratios. This is our acronym, SOHCAHTOA. SOHCAHTOA. All right, put a sock on your TOA. All right, so information, make sure you write this down. You're going to need to memorize this. You're going to need to remember this, because this is going to come in very handy. So when we're looking at a triangle, all right, so if I take this triangle here, and this is angle A, and this is angle B, and then this would be angle C. And we'll do this lowercase a, lowercase b, and c. So if I asked you to tell me what is the ratio of sine A, what would that be? So sine A is this angle. So opposite is what letter? Lowercase a, good. And what is it going to be over? Opposite over the Genesis. Hypotenuse, good. So C. So that would be our ratio. So what if I wanted cosine A? So what would cosine A be? So cosine A, Devin, cosine A. Cosine A, what is it? Adjacent. So which one of these sides, A, B, or C, is the adjacent side to cosine A? Devin? B. That is correct. It's just like your grade, a B. Wonderful. So it's B over Jenna's grade, which is a C. Good. All right, wonderful. Now, anybody have any questions so far? If you do, awesome, because I can't answer them, because I don't even know if you're paying attention. Hopefully you're listening. So Tyler, let's do tangent A. Tangent A. So tangent is what? Opposite over adjacent. Opposite over adjacent. So opposite leg of tangent A is lowercase a. Tangent of B, the adjacent, is B. That is correct. Is everybody following this? So if I asked you to find cosine B or cosine A, could you do it? Well, of course you can. So if I were to do cosine B, what would the ratio of cosine B be? So now let's think about that tally. Tally, what do you think cosine B is? It is the side that is adjacent, right? Adjacent, which is A, good, over hypotenuse, which is C. Can you guys match which ones will go together? Very good. Sine A, cosine B. So can somebody tell me what sine B would be? What's the ratio for sine B? Hope? Not Faith, Hope. Thank you, Hope, good job. And that's going to be B over C. This one goes with this one. They're the same ratio. All right, any questions? All right, so that's important. That's the concept. Now let's do some problems. So this is going to give us the lengths of our triangles, and then it's going to help us find our degree, because A, B, and C represent our degrees. We know this one's 90, so we're going to find this degree using sine angle equals what over what. So those numbers are important, all right? So remember our drawing, remember our association, and let's go from there, all right? So we're going to erase this. I need my board, so I'll leave my acronym up so I know what lesson I'm in here. All right, so first problem. Looks like this. 5, right angle, 9, A, B, C. So if I asked you to find the ratio of sine A, what would it be? Sine A. So sine A equals what over what? Opposite 5 over hypotenuse 9. Good. So there's our ratio. Good. Now, question. If I asked you for cosine A, what is cosine A? Adjacent. Does anybody see a problem? Adjacent, which we don't know, over the hypotenuse. So how can we find this leg? Good. Pythagorean theorem. Well done, John. John, nice job. I'm going to give you a bonus point for that. Getting the answer right without even being called on. So use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. So our a, 5 squared, plus b squared, c squared, 9 squared, right? So if we do the math on that, we're left with 25 plus b squared equals 81. Subtract 25, subtract 25. B squared equals 6. I'm left 7, 56. So b equals the square root of 56. Can you reduce this to 2 and 18? 2 and 28. 2 and 14. So we know that's the last of it, right? Is that right? Yeah, 18, 20, 28, good. So it's going to be 2 to the square root of 14, right? So 2 to the square root of 14. So cosine A is what? 2 to the square root of 14 over 9. So this is 2 square root of 14. Now, class, here's where it gets interesting. What if I asked you for tangent A? tangent A. Anthony, great job for paying attention. I know you're on your couch, half asleep, covered up in a blanket, but you're always paying attention. So Anthony, tangent A, what over what? Opposite, good. What's opposite? 5 over adjacent, which is 2, the square root of 14. Now, listen carefully, class. There's one thing you cannot do in math class, in math. You can never leave the square root in the basement. Because if you have a square in the basement, it messes everything up. So, you must work that out to come to the top, all right? So, how do we do that? Here's what we do. Tangent A equals, so we're going to multiply the top and the bottom by the square root of 14. So you're left with 5 to the square root of 14 over 2 times 14, which is 28. So there's your final answer. In order to be academically correct, you